Hello everyone, it's October 6th. Alright, as was yesterday, we've done it. Let's move on. Avoid flood in the city. Your country has an infinite number of lakes. Initially all the lakes are empty, but when it rains over the nth lake becomes full of water. If it rains over a lake that is full of water, there will be flood. Your goal is to avoid floods in any lake. Okay? Given an integer array rains, where rains I larger equal to 0 means there will be rain over the rains lake. If it's equal to 0, that means there are no rains this day. And you can choose one lake this day and then dry it. Return an array answer where answer I equal -1 if rings I equal larger than 0. Answer I is the lake you choose to dry in the ith day if rings I equal to 0. If you choose to dry a full lake, it becomes empty, and if you choose to dry an empty lake, nothing changes. Wait, hold a second. It says if it rains over the nth lake becomes full of water. If it rains over a lake that is full of water, there will be a flood. If it's larger than 0, rings I larger than 0, there will be rains over the rings I. What does rings I lake mean? Oh, rings I is the index of the lake. So if it's equal to 0, that means no rains. If it's larger than 0, then that lake gets flooded. So basically, what we want to do is, if rings I larger than 0, which means there will be rain. There will be rain over that lake, so we cannot dry any lake. But if rings I is equal to 0, then you can choose one lake to drain. And rings answer I is the lake you choose to dry on the ith day. If there are multiple, wait, hold on. What is the goal? Your goal is to avoid floods in any lake. So okay, I have just try. Will this be possible? Or rain 4 days on the same on the same. Oh. If it is impossible to avoid, return empty. Oh, if you choose to dry a full lake, it becomes empty. And if you choose to dry an empty, there's nothing change. So basically, we have this arrangement that, so we want to avoid the same getting hit twice. So here, counter, then everybody will hit once, so it's fine. We don't have to drain anything. So the second one is 1, 2, 0, 0, 2, 1. So each one gets hit twice, which means whenever it's 0, actually we should ignore 0. So 1 gets hit twice, 2 gets hit twice, right? So 1 gets hit twice, 2 gets hit twice, which means I need 1. So like this divided by 2 is how many dry day I need. So this one requires 1 dry day, this requires 1 dry day. So in total I require 2 dry days. And I see I have 0, I have 2, which means I can do it. So the answer will be -1, -1, and then we just, you know, the first one. Oh, it has to be something that has already been taken. Oh, I can just go through, like there's a 1 and a 1 and a 0. You have to dry something, right? You have to dry some of them. So you just do 1. Which one would you decide? Well, it actually depends. I do have to take the total. So this is the total idea, right? And then I need to go through this again anyway. So -1, so I have a 0. Then I know so far I just need to coordinate it. So far, because I know I need to take 1 day for 1 day for 2, but it also requires us to know when do we need to do this, right? So we need to take 1 day for 1 day for 2. Okay, so this is what I know, right? And then yeah, so we do this, and then what if it's 3? Oh, you need to take 3 so we can have rain, drain, rain, drain, and then rain, right? So if it's even, is a half. If it's odd, like 3, so it's going to be +1 divided by 2. That's the number of drain that we need, right? Because if it's 3, you have to drain twice, and then you count, so it's fine. So it's the number of times that needs to be drained, right? The number of times that needs to be drained, which can be, so I need to go through this. Okay, I need to go through this, find out the number of times it needs to be drained. Okay, so I updated to 1, updated to 1. This is the number of times they need to be drained. And then find the sum. If the sum is smaller or equal to 0, that means we're good to go. Otherwise, we are not. So if it's good to go, then I go blah, blah. So I hit a 0, right? I hit a 0, and then I can, I don't know, like 2 pointers or what? I can do a deck actually. So like just this one comes out, I see if I can do one. I say yes, I need to do one. I pop out, and then we can do this. I wonder if we can do it without. So it's like 2 pointers. Yeah, we can do 2 pointers. So 1 pointer go and hit a 0, and then we hit the other one. If it's 0, we just skip. If it's not, then we just do this. And every time we go, this becomes 0, right? Which means if we hit it again, if it's a 0, we can also go. And it sounds about right. It sounds about right. I think we can code it up and call it a day. I think there's a lot of weightlifting content I can consume today. So it's at 1488. Count. Do a counter on rains for a non-zero value, right? For a non-zero value, the number of drying days is counter I plus 1 divided by 2, right? if the sum of the non-zero counts is not bigger than the count, or than the zero count, we can actually, that is not true. That is not true. Because I can have the drying days before. Alright, so yeah, we can actually show, like, if I have this, I need 3 days. 1, 2, 3. This is still 0. Because the 3 drying days is you're not gonna dry anything. So the answer should still be empty. Yes. The answer still should be empty. Okay, so this is actually not right. Yeah, so if the sum of them is not bigger than 0, we immediately can return empty array because there are not enough drying days. Otherwise, we iterate through range again and try to drain the lake. Right, try to drain the lake according to the number of drying days required for each lake. Right, each lake. If at any point of iteration there is no drying day left, right? There's no drying. What do you mean there's no drying? It's just, you hit a 0 and then you hit this. So every time you hit this, you need to dry, but you cannot dry. It's actually towards the end, right? Because at that point, you don't have drying days anymore, right? You don't have drying days anymore. So you hit a 0, you should remove it, right? You should remove it. So yeah. Otherwise, we turn through and try to drain the layer according to them. At the end, of the iteration, all the non-zero counts should become 0. We update the counter by replacing the count for each non-zero value with the number of dryings it requires. Right. So at the end of all the non-zero values, drying days, drying requirements, right? Drying requirements should become 0. If not, that is an impossible case as well. Alright, so now we can do it. So what we need is a counter, but maybe we don't need a counter. 10 to the 9th. Alright, we need a counter. Unordered map. Int counter. Yep. So for int r of range counter r plus plus. Okay, so that's that. And then for const auto key value, right, of counter dot items. Actually, maybe it's counter. if k is larger than 0, right? K is larger than 0. Yeah, if k is larger than 0, counter k shall equal to const auto. Maybe we should do this. Right? V plus 1 divided by 2. Okay, so now we update it. Okay, now we're gonna do it again. So we can say int I equal to 0 for int j equal to 0. J is smaller than range dot size j plus plus. Okay. If so, every time the j, I shall I also need answer. Okay, so the first one, right? If it's 0, then we can do. If it's not a 0, all right. So we say if range j is not a 0, then rest j should equal to -1 because we cannot do anything. Okay. Else, so range j is a 0. Now we need to see is which one we can remove. So we should say while I is smaller than j. Okay. Now I'm gonna check if range I is equal to 0 or counter range I actually dot at range I is, if it's a 0 or counter, which means it's also 0. This means I don't need to drain anything. So if that's the case, I plus plus. Right? If this, then I plus plus. Else, I think I need the I plus plus as well. So else, and I need the I plus plus as well. So it might as well not I plus plus here. So it should be, if it's not equal to 0, right? And this is not equal to 0. Okay, so we can put this one in here, reduce this one. Yep. So if the current range I is not equal to 0 and it doesn't have, it still requires reducing. So if that's the case, I should also check. Right, we should also check. Because I shouldn't move forward if there is no 0, right? It's also depending on the 0. Shall we move forward? So this situation means I'm ready to be drained, right? I'm ready to be dried. So depends on, I can do continue. Okay, so if counter dot at 0 is larger than 0, right? So drying is possible. If drying is possible, okay, then what do? Is we'll dry it. So we say res j shall equal to I No, rings I. Right, so we'll dry that, and then counter rings I minus minus, and counter 0 minus minus, because we dried a day and then we used up a day, right? We used up a day. I think this is always, we're gonna always counter. Yeah, so we hit a 0 and then we check, right? We check. So once we check it, okay, we only dry one and then we go to the next one, right? So it's either not. So actually this one, hold on, this one need to wait. So basically this is good. We don't keep going, right? We don't keep, even if I have multiple zeros, do we not? Because I hit the first 0, I hit a 0, right? I hit a 0, okay? Then we'll go from left to right, and then I will try it. So I hit a 0, and then, yeah, if I hit a 0, and there's nothing on the left, and then that 0 is basically wasted. So I don't really need to do any counting on a 0. It's just wasted, right? It's just wasted. So yeah, I hit a 0, I check the I, go from left to right. I don't have to check. I don't have to check this because I am at 0 right now, right? So I am at 0 right now. So drying is possible because I am at 0, right? So we go from left to right. I is smaller than j, and I find one that can be dried. I'll dry it, and then this one minus minus. Done, right? That's it. This is it. We dried it, and then I plus plus. I need to plus plus, right? Because I dried it. I plus plus, then we break, right? I plus plus, then we need to break because I finished the drying. Done. I can't move on to the next one because I don't have another 0, right? Otherwise, if this doesn't satisfy, right? If this doesn't satisfy, then I just plus plus, plus plus, plus plus until I couldn't do it anymore, right? Then this is 0 just wasted. So we get out, and then yeah, that's just it. Just move on. And what happened to this position? What happened to the J position? It's a 0, but we can dry, or I cannot dry anything, which means I need a test case of, let's say I have this. What do we do when it's a 0? Now we don't do anything. I don't know. What is the required output in that case? We can dry anything. We can dry any. So we can dry. So basically, in this case, we tried everything, but so yeah. So I tried from left to right. So we have an I, right? And then I tried this, and then it's not. Then if it's not equal to 0, and then it's can I answer 0? Can I answer 0? Actually, I'm not sure. Is it possible that I answer 0? Because I don't want to keep track. Not sure. Probably not. I think 0 probably is not allowed. Yeah, you cannot do 0. So I have to record the 1 that is not a 0, right? Okay, so now what? So right now is not equal to 0, right? So if right now is equal to 0, yeah, it's just we skip, and then this I will have it. So basically this has to be a separate condition. I cannot put it together. I have to say, oopsie doozy. I have to say if, okay? And yeah, something like that. I have to say if, and then else. We need to have, let's say, you break it out. So you break it out. Because you might have how do I know? How do I know? If you go minimum, right? So we can say int no need to dry lake. So you set a negative value, right? So if it's not, then I need to say no need to drain is equal to minimum no need to drain lake and rings I. Alright, this cannot be this. It has to be int max. Okay. And then no need to drain. So this is drying as possible. So I dried it. And after I dried it, we say no need to dry lake with -1. So which means even if I hit another one that does not but you break out. Oh yeah, you break out. And I set this to -1. So if everybody has no need to dry, so I would just get the yeah, because it has to be not equal to 0, right? So I got a 1, no need to dry. And if I hit something that should dry, I'll set to -1 and I will break it. Right? I will break it. So during this entire course, right? During this entire course, okay? During this entire course, and then this is, yes, I plus plus. So when I get out, right? When I get out during this entire course, when I get out, I can check no need to dry lake, right? So the no need to dry lake, either it should be -1. That means we have dried a lake, right? Or it should be some other value, which means we just simply don't need to dry. So if it's not equal to 0, right? And I'm at 0, right? I am at 0. And hey, hold on, what's this? This is empty. So I am at 0, and then no need to dry. Huh. So no need to dry is int max. Interesting. How about yep. So what would you put in the 0? Oh shoot. Ha. Okay. Okay. So you should pick any to dry, right? Anyone to dry. So in that case, oof. Maybe we should just put them as a marker. Like no need to dry lake. We put it as an int max. We just keep it as int max. Right? Otherwise it will be some value. It will be -1. But -1 is, that just means, so if no need to dry is -1, that means it has already been set. So we don't set it. Otherwise it will do it. So we'll do it, and then it will be the int max, which is fine. And then we go towards the end. Right? We go towards the end. So when we are at the end, we need to check. Right, we need to check if any of the values that's, yeah, then we can return empty. If everybody's good, then we will just pick whatever. In that case, we don't even have to, because this is no need to dry, right? So I just, no need to dry. Yeah, no need to dry. We do int max, and then we actually don't need this part. This is not necessary, right? So it's just, yeah, I just need to pick a, so this shall do. Okay. No need to dry. And I++. And then we say if no need to dry is larger than 0, because I do int max, then we'll say res j is equal to no need to dry. It's just a marker that, so this is a marker, like a marker that we can put any lake here, right? Okay, so this is not equal to 0, has to be this. If it's equal to 0, we will search from left to right for a lake that needs to be dried, and we find it, we'll dry it, and then we reduce this, set it to -1. I'll need to ++, and I'll break this one out, otherwise I'll continue. We can say and no need to dry is larger than 0. And if I set this, then I don't need to do this. Right, I set it to -1. I think it's easier. We can say lake dried. Okay, lake dried, we do int max, and then lake dried if it's larger than 0, which no lake dried, right? No lake dried. Then we say no lake dried becomes this, and no lake dried, no lake dried. Okay, right, so it's a plus plus, no lake dried will get out. So this is good. Actually, I forgot one thing. I should do this. Int total drying equal to 0, right? And I say total drying plus equal to counter dot add k, because I already updated, right? To this. And now we say if total drying needed is larger than counter dot add 0, then we shall return empty array. Yeah, this is just not possible. And otherwise, blah blah blah. So now we're at the end. We go through the whole thing. So next we just need to see if there is any counter, right? So check if any non-zero value has count larger than 0, right? If so, that means that lake will be flooded. So again, we say for const auto kv of counter, yeah, because I'm constantly changing. If v is larger than 0, if k is not equal to 0, and v is larger than 0, then we return this. Yeah, this is not possible. Otherwise, it's possible. Then we need to go through the whole thing and then swap the int max with some non-zero thing to swap. All right, so int lake to dry. So if k is not equal to 0, if this is larger than 0, right, we'll return, and else we'll say lake to dry equal to k. Doesn't matter, I can just do this. Which you can just do the last one. But it's alright. So now we go through this. We've done the check. Right, and then we have to run one more time for int I0 is smaller than rings. I can say res.size I plus if res I is equal to int max, res I shall equal to lake to dry, and then we'll return res. All right, so a little bit convoluted the logic. Out of range. Where? Unordered map. At. Oh, it might not have 0. Oh man, I think I've done this before. It might not have 0. Yeah, it might not have 0. Ooh. But hold a second. If I have 1, oh, 1 is fine. 1 requires, so it should be divided by 2? But 3 requires 2 days, right? Hold a second. But we can have a fill 1. So it shall be v minus 1. Right? V minus 1 is the access. Right? If v minus, so if it's 3, right? 3 minus 1 is 2. So I need 2 days to drain, to dry. So this is not divided by 2. This should just be v minus 1. Because I allow 1. I don't know why you say divide by 2. You just allow 1 day, and then you should just do that. Okay, let's give it one more shot. Yep, this one looks about right. Let's take a look. That is not correct. 1100. So 1, 1. So the first one, I think we need to update the logic. Oh yeah. Oh yeah, this one is wrong. If it's not equal to 0, right? And because this is the number of days. So yeah, so basically I hit it. I hit a 1, right? And I know the number of draining days I need. I actually wonder if I need to do that in the first place. Maybe I don't even need to do that. I just do the counter straight away, right? You get 1, you hit, and then once you do, and you just keep it at 1, right? Just keep it at 1. Maybe I don't need to get this fancy. Do a counter on reigns. Right, each time a 0 is encountered, try to dry a lake that needs to be dried. Right. If a non-zero value is encountered and the counter is already non-zero, that is flooding. So I don't think I need this, and I don't think I need any of this. I think we will just start like that. Okay? So we say if range j is not equal to 0, if counter range j is equal to 0, right? If it's equal to 0, then counter range j. Hold on. Let's do this. If counter dot contains range j, okay? If it contains range j, if counter does not contain, counter dot contains range j, right? If it does not contain, might as well just say counter range j plus plus, right? And then I can say at if this is larger than 1, because I allow 1, right? If it's larger than 1, then return this. Otherwise, if it's not larger than 1, it's just equal to 1, that'll do -1, right? Otherwise, now it's a 0, right? So I go from left to right, and then I will see if it's not equal to 0, so I'll dry it. Right, if it's not equal to 0, then I will dry. But if you do that, you might dry things you don't need to dry, and you're wasting. Right, then you're wasting. Yeah, that's the thing. You might not. So this is still has a value. So this will tell you how much we need to dry, right? How much we need to dry. And then if it's not equal to 0, I need to see how much you need to dry. Like we know this need to dry, I need to dry 1, right? So if it's not equal to 0, then I shall do a -1. But that depends on if, so when you do -1, like this will tell you that I need to dry 1, right? I need to dry 1. So the number dried, the number to dry is 1, which means if, so we need another counter. Number to dry. Because if you don't need to dry, right? You don't need to dry, you can just skip. But now you hit 1, and how do you know this one needs to dry? feel I need another. I feel I need another counter. Because I need to know. Because the current counter only tells me the number to dry, right? The number to dry. So like if I do it, the number to dry will decrease. But, which also means if I first encounter it, and then the second time I encounter it, how do I know it's the second time I encounter it? Right? How do you know? You don't know. Right? You don't know. Yeah, I feel like I need another counter. I need a counter for number to dry. So we know if something that does not need to dry, we can skip it, right? This is what we want to know. If we can skip. But we also need to know the current. So we know if we have multiple, right? Like this scenario. It feels very convoluted. So this counter is not a counter. So I need a counter to dry, a dry count. Okay. So we're gonna start with dry count. Right, this is a dry count. Actually, all of this can do a dry count. Dry count, dry count, dry count, dry count, dry count. Okay. So now we can say counter range j or b++, right? And then if counter dot at range j is larger than 1, immediately return. Okay. Otherwise, if it's equal to 1, that's fine. I set it to -1. And then if it's a 0, dry count, and then counter range I is also minus minus. Right, also minus minus. So we kind of need to keep the counter. Oh, then why don't you just use the counter? Why do you need a dry count? I don't understand. What's the purpose of dry count? I think a counter is enough. Right? Well, the dry count tells us which one needs, but if I just do a counter and then you come through and you find out that the counter value is 1, right? Which means you don't need, you can skip it. Yeah. And what's the point of using them? You don't need a dry count. I don't think so. I still think you don't need any of this. Okay, you don't need any of this. We have a counter, we have this, right? We have this is the result. And then every time you hit it, you do this, and if it's larger than, perfect. Otherwise, you do this, and this shall be, counter dot add this if it's I mean, you might have drained it already, right? But it doesn't matter. So draining is possible. So if it's larger than 1, right? If you have larger than 1, then you need to drain it, right? You drain it. If it's not larger than 1, it's equal to 1, or if it's 0, then it's fine, right? You just move on to the next, move on to the next, move on to the next. If I come out and nothing, we do this, right? And then we'll check if any, we don't need to check this, right? Because we will have checked already. So this is not necessary, right? This is not necessary. But we do need a lake to dry. Actually, we don't really, it doesn't really matter, does it? Lake to dry. Yeah, we can do lake to dry, we can put lake to dry here. We do lake to dry. And then every time when we do this, we say lake to dry is equal to that, because this is a lake, right? This is a lake, so equal to equal to rings j. This is a lake to dry. And then we don't need any of this. Right, do counter on the rain. If at any time, if a lake's count is larger than 1, we have flood, right? And at any 0 value, we search from left to right the, wait, but don't you have the same problem? Right, you hit a 0, and then you go left to right. You could have drained a 2, right? If I have like a 1, 2, 0, okay, and then 2, 0. Yeah, so the 0, I have 2 choices, right? I either drain this or I drain this. And I decided to drain 2. Because later on I can say I have 2 of them. But it's fine. Because you use it, if you use it, and just use it. Right? Like later on, if you do 2, if you do 1, yeah, it does matter. It does matter. I can think of this case, like we have 1, 2, 0, and 2. Right? This is possible. This is good. And this is good because this 1 needs to be skipped. 2 also need to be skipped. In this case, I both will be skipped. I'm not draining anything. But that's wrong. I need to drain 2 because I have a 2 again. So you do have to have an overall idea, right? You need to have an overall idea of which one to let go. Like this overall idea is this I can let go because overall I have 1, right? That's fine. But this one is not. So this one needs to get drained, right? This one needs to get drained. So I do need the overall counter. But then in this case, the overall counter, right, is 2. So when I hit the first 0, we need to reduce it. But before I hit the first 0, so I do need 2 counters. This is okay. I'll have to go back again. Yeah. Yeah, do a counter. This helps us understand which lake should be drained when an opportunity presents itself. Do a counter. We need a second counter to check whether at any point a non-zero lake can accumulate more than 2 counts. If so, that is a flood. All right, so we have basically counter 1. I just call it counter, right? This is a counter. And we have a total dry-in. So this is just a quick check. And then I need an ordered map int counter 2. Okay. So counter 2 range j, right, plus if counter 2 range at range j is larger than 1, return this, right? Otherwise we do this. And then here we do need to check counter, right? If counter is not equal to 0, that means this is something that we should drain. So we drain it, and then also counter 2 range I should minus as well, right? Not equal to 0. Now we hit the 0. Yeah, so we should because we drained it, right? We drained it. So blah blah blah, we go to the end. So lake to dry. I think this is still good, right? So lake to dry is equal to range j. And anytime this is bad, I will know. Check if any non-zero value has counter larger than 0. Well, we should already be able to detect just by using counter 2. So I think this part is not necessary, but this part is necessary. All right, anyone that Cannot. It should already be identified. All right, let's try this one. Okay, let's try it. Progress, but all right, let's see. 1, 2, 0, 2, 3, 0, 1. So 0 is 2, 1 is 2, 2 is 2, 3 is 1, minus 1, minus 1, this is 0. So I should not get here. Right, so if it's larger than 0, counter k is v minus 1. Yes. So total drying is 2, so it should be fine. And we have a counter 2, so counter 2 plus plus, so that's a 1. This is a 1. All fine, so we found a 0. Right, we found a 0. And I and counter is not equal to 0. That's true. So counter, yes. So counter minus 1. So that becomes 0. Right, that becomes 0. So it doesn't. We don't need to reduce any one of this. And counter 2 is also becomes 0. So no lake is -1. And then boom, come up. So I is pointing to this one, okay? And no lake is larger than 0. No is -1. So I move on. 2 again. Ooh. 2 again. Damn. So in this case, I shall prioritize this 2. Huh. All right, I think we need to change strategy. This is not working. This is apparently not working. Oh, but this is working. It's great. So this is working. So this one is successful. Yeah, I'm working at the same time. Right, success. Now I need to do part 2. So need to do part 2. Stop failures. Is that what we did last time? I think so. All right, let's do this one more time. Nice. Let me record it, and we are here. Okay, it's back. Fill part 2. And we have the link. Okay, job's running again. All right, let's go back here. It feels like I should do counter, and I do a counter on 0. Okay, so I just do -1, the -1. I record where the 0 is, so we don't know. Okay, we just put a 0. And then we hit here. Now counter says 2 has 2. So I need to look for the previous 0. Make this into a 2. Right? Make this into a 2. So now this I can be -1. 3 is only 1. 0 I skip. Going to 1. And then I will do a -1. What if we have multiple zeros? Doesn't matter, right? If the 0 you already done, it's just wasted, right? It's just wasted. Wow, we are going to change how we code this completely. Okay, use a counter on range, right? If as we iterate through range, we keep track of the last 0 of the index of the last 0. If the current non-zero lake has more than 1 count, we check if there was a unused 0 before. If so, we use it, right, to dry the current lake. Otherwise, return empty array. Something like that. So we have a counter, so we don't need any of this, right? Any of this is not necessary. We don't need any of this. We do need lake to dry. Okay, lake to dry. We need to just, yeah. So in the result, we don't need this. And all right, let's just redo the entire thing. For int I, 0i smaller than range dot size I plus plus. Okay. 0. Oh, last 0. So int is last 0 index -1, which means it hasn't occurred yet. So if range I is equal to 0, we say last 0 index will equal to I. Okay. Else we do range counter range I plus plus. If counter range I, that's actually not right. We should use .at. Right? If this is larger than 1, then we need to check. If last 0 index is larger than 0, then we can do something. Else, we just return this. Okay? And Yeah, we can set it to 0. So that one need to we need to dry it, right? How do we dry it? We say res last 0 index shall equal to range I, right? Shall equal to range I. This is drained. Then after we drain, this will be -1, and then counter range I need to minus. Right, and what about -1? So you drain the previous one, so the current one is fine. So this is, if it's larger than 1, then we do this, right? And this is to drain the previous one, so the current one, we can say res I shall equal to -1, right? Shall equal to -1. And when we get to the end, I need to know, right? I need to know what to put for all the zeros. So to put to the zeros, what I need is here we say lake to dry, lake to dry shall equal to, no, I don't know. I'm just gonna do range I, because it doesn't matter. So when the end is here, we say for int I 0, I smaller than res dot size I plus, say if res I is equal to 0, then res I can equal to lake to dry, and then we will return res. All right, this one I think it's correct, and it has much simpler logic as well. We should actually use the test case. Ugh, what the hell? Lord, this is so hard. I thought it was not a difficult question. Yeah. So when I hit this one, right? When I hit this one, how do I know I have a 0 that's unused? Right? I hit this 0, but I hit a 0 and it's just unused. So I need to keep track of all the unused zeros. Okay? So unused zeros, not last 0 index. I say maybe a stack int unused zeros. Okay, so every time we have a 0, we say unused zeros dot push I. Okay, this is unused zeros. So once I do this, if it's larger than 1, and I check, right, if unused zeros dot empty, if it's not empty, then int j shall equal to unused zeros dot pop. No, I think it's top. Unused zeros dot pop, and then j will equal to this, and I already popped. Okay, I'll try one more time. Unbelievable. We're hitting 1 hour and a half. Simply just don't want to give up, because I feel this one is within my grasp. Alright. Come on. Come on. Dear Lord. Yep, it's not right. Holy crap. Because this 0 is basically useless, right? So I do have an unused, but there, how do you, yeah, because you push it in, so the latest has to be, right? The latest has to be, so the earliest, so you need to know your earliest. So instead of a counter, what you need is to have a deck. It has to be a deck, right? It has to be a deck. So instead of a counter, it has to be a deck. So what I'm saying is this is going to be a deck of int. It's just positions. It's not a counter. Position. So we don't need this. Okay. So if it's this, what we do is position 0 dot push dot push back, right? So I'll push back I, and this will be position range I dot push back I, the position. So this says position dot at this dot size if it's larger than 1. Okay, that means I need to pop. So what I need to check is, so we need to check whether the latest 0 is later than the earliest range I. So here, what we're gonna do is if position dot contains 0 and position dot at 0 is not empty, and position dot at 0 dot back is larger than position dot at rings I dot front. If this all satisfies, then, because I always use the latest one, right? But you shouldn't use the latest one. You should use the one, because now you're saying when you hit something And then we always check the latest, so you use the latest. But then you can have something else. Yeah, you shouldn't use the latest. You should use the like the earliest. So actually here we it should be, we shall pop the position that's, useless, right? The useless positions, because it's the first one that we requires. And then I just should use the first one. We're gonna pop until the first one, and then that's the one we're gonna use. Okay. So we say while position dot contains 0 and this is not empty. Yes, this is not empty. And position dot at 0 dot front. If this is smaller than position dot at range I dot front, right? If this is 0 is in the front, so this is useless, right? This is useless. I need a first one, but if you pop it, maybe somebody else can use it, right? Somebody else can use it. All right, this is taking way too long. I think I have to editorial this and then call it a day today. Yeah, I do think we need binary search. No, I haven't done this one before. Well, I'll just do it and then we'll get back to this other day. Yeah, this is more complicated than I thought. It's pretty hard, actually. Yeah, I feel like this is pretty hard. Anyway, I'm gonna